record for us. All right. And without further ado, let's hand this off to today's speaker. Adib, off to you.
All right. I guess I do need to share my screen, right?
Hey, let's do that. Yes.
Okay. All right. And are you able to see my slides?
I see it. See the slides right now.
All right. Excellent. Welcome everyone to today's webinar on demystifying the agentic loop. I have a few slides just to kind of set the stage for what we're talking about, and then I'm going to switch into code, and you're going to see all of this stuff in action. This originated as like a full day workshop, about 8 hours. And so I've had to shrink the content quite a bit in order to fit in the time frame that we have, the 1 hour. So the first thing I want to start with is what's an agent really? And for that, I want to introduce this idea of the application capability continuum. And let's consider a scenario of we want to build restaurant reservation app, something like OpenTable. I'm sure many of you have used it. And so if you imagine like what's the architecture for a restaurant reservation app, you might see something like, well, I have a UI, I have a backend, and I have a database. And we've done this for the last decade. So everybody on this call knows how to do that in Spring. But let's think a little bit about the business aspect of this. So, how does the app work? It matches diners to restaurants, and that's how they make money. The more bookings they get the restaurants, the more the restaurants pays them. But if you open up your OpenTable app or your restaurant reservation app in a big city, you might find thousands of restaurants. This was Gemini's best guess on how many reservable restaurants there are in a various cities. So, where I live in Toronto, there's probably 4,000 restaurants that you can reserve. So if I open this up and it suggests to me pizza places, not good because I don't like cheese. So in order to increase revenue, we need to decide which of these thousands of restaurants are we going to show the user. And this is where people have traditionally done things like machine learning in order to say, let's train a recommendation model based on the booking history that we have. Because the app knows which restaurants I've booked, it knows what my preferences are. And so you could train a model that says the most likely out of these 4,000 restaurants in Toronto, these are the most likely that Adib's going to want to pick. And if I'm in a different city traveling, can use that information. So recommendations kind of move from being a hard-coded rule to a user-specific probability ranking. And this can directly improve the core business metrics. And the downside is we need people who are specialists in training machine learning models, right? And for many years, this was what AI meant, about building these things. So architecturally, you would say like, hey, now I have my backend. I'm going to train this model. I'm going to take this prediction model. I'm going to deploy it somewhere, make it available over a REST API, and then my backend is going to call it. And that's how I create predictions. So now that gets us to the next problem we have to solve, which is the users of this app will have unanswered questions about the restaurant. Maybe they want to know things about like, does it have a gluten-free menu items? Is it good vegetarian options? What's the noise level? All of these questions need to be answered in order to make a booking. And if the users have questions and it's not easy to answer them, they hesitate. And when they hesitate, they abandon the booking. And so being able to quickly answer questions about the restaurant is a good way to get more bookings. So how do we solve this? This is where we can start introducing Gen AI. So maybe we build a restaurant Q&A service, which is going to accept natural language questions from users. And then we're going to gather the information from our restaurant database and use an LLM in order to generate an answer. So now that we can give clear answers, we can reduce friction and hesitation, and that gives us more bookings and hopefully more revenue. So our architecture evolves to look something like my backend is going to now still call the database it had before. It's still going to call the prediction model that's trained in-house. But now we have this new Q&A service over here, which is going to use a Gen AI foundation model, something like ChatGPT or Claude or Gemini or Kimi or K3 or whatever it happens to be. And that's great. But then we run into the next problem, which is that planning causes frictions because our users aren't just booking for a meal. They might be booking a business lunch, they might be booking a business dinner, maybe they're booking an anniversary, maybe they just want to hang out with their friends. And so when you're trying to plan amongst a group, you've all done it before, trying to get everybody to agree on a date, on a time, and then finding a venue can take some effort. So if you're doing that manually, you can do that as the human acting as the agent and clickety click in the restaurant planning app, but then, that takes effort and then you might abandon bookings. Now imagine if there was a planning agent or a planning service in the booking application, then it could take care of that. So our next thing that we want is an agentic version of this restaurant booking application, and we're going to introduce an agent planning service. Now, the agent is going to figure out what are the user's goals. It's going to reason over the constraints, for example, meal preferences, the type of event, location, driving times, that kind of stuff. And then it's going to recommend some answers and next steps. So now planning is going to be handled on behalf of the user. This reduces friction, increases bookings, hopefully makes more money for the app. Architecturally, what that looks like is we're adding a new service to our architecture that the backend is going to call, and that's our experience planning agent, which is going to use foundation models to generate something, but it's also going to use external APIs. For example, it could be calling out to I don't know, like Google Maps, for example, to find out how long it would take somebody to get from one of the attendees from where they are to the restaurant, right? That's being proposed. Maybe you have a distance travel constraint. So the reason why I present these is that that's what I call the application capability continuum. You can think of an application kind of, we've all very familiar with interactive applications. These are all really about business rules and data. The CRUD apps, they have static decision logic in them. And the next step up is where you can evolve your interactive application into a machine learning application, which is really focused on has some element of prediction in it, some element of probability. And really, we're learning behavior from data that's been collected in the application. We're computing user-specific likelihoods and scores. It's all about ranking and scoring for the most part. You go to the next kind of step in this continuum, and you're at the natural language input, contextual answers, and that's like question answering, aka what a lot of people call RAG, right? And then the next step up is really about building agents, and that's where it's all about planning and actions. We need to understand the user's goals and the user's constraints, and then we need to come up with a multi-step plan, and then we can figure out how to satisfy that. So if we take this model, I argue that you can pick any domain and you can kind of ask yourself, what is the interactive version, machine learning version, Gen AI version, and agentic version of that? So if you look at something we're all familiar with, like writing code, your interactive app might be the IDE with syntax highlighting. The machine learning app might be some sort of completion model, content assist that suggests things based on statistics. The Gen AI app might be like, explain to me how this code works. And the Agentic app might be like the coding agent you all use, like go implement this feature. Maybe an easier to see one is with like, say, applying for a loan. Your web app to apply for a loan, that's the interactive app. The machine learning version maybe adds credit scoring and risk assessment into it. The Gen AI version might explain all the different loan options you have. Maybe you want to get a mortgage and it's a variable rate mortgage or a fixed rate, 5 year, 3 year, open. There's all these things that people may not know, and then your app could explain to them what their options are. And then the agentic version of that might be like helping you actually gather all your documents and submit the application, all that type of stuff. So I'm not going to get into more of this table here. I hope you got an idea. Are there any questions so far about this continuum? All right.
No questions so far.
Okay, excellent. So the next thing I want to talk about is what I think is I think of it as the iron law of agents. This is the most important thing about an agent, which is the acceptance rate, because the acceptance rate is the most important thing. But let's define what it is. It's the percentage of tasks that the agent completes without user correction, override, or retry. Think about it like this. If you ask the agent to do something for you and it only does what you want 30% of the time, you're not going to like that agent. You're going to be like, oh man, that's not a very good agent. If the agent does what you want 80% of the time, you're like, okay, that's worth my time. 20% of the time, it's not doing what I want, but it's better than 70%. Now, if you can get an agent that does 100% of what you want, that's amazing. I don't think that exists. But what I'm trying to get at is that you want your agent to have a very high acceptance rate, which means you need to measure that acceptance rate, right? And so the sad reality is that, well, the point here I'm making is the acceptance rate, it really governs agent systems. And without it, no one will trust your agent. It doesn't matter that you use the fanciest model out there, Fable 5 or GPT 5.6 Soul. If it doesn't do what your user wants, it failed. Now, you're not going to get to 100% acceptance rate because, models are probabilistic. Planning might introduce some errors. The tools that you're using can fail. The context is incomplete. Constraints can be misunderstood. So our goal is not perfection, it's disciplined improvement. And the reality is, in what I'm going to show you today, even though I just told you that the acceptance rate is the most important thing, we don't actually have time to cover it. Okay. We don't have time to explain how to measure it. We don't have time to explain how to improve it. But for sake of mental model, I want to tell you that you can do it all in Spring. And also, you're going to need stuff that is beyond Spring. You're going to need some sort of platform to run the agent where you can easily collect all of these types of metrics that allow you to measure the acceptance rate. And one of the things about where the failure that lower the acceptance rate come from, they can come from many different places. And you have to figure out how to define success for the agent, how to judge the outputs, and understand how the system produces the results. So, with that said, here's a really quick explanation of where these things fail. You have your application front end to your back end, to your agent code, to the foundation model. You could have infrastructure and API failures. The user blames you even though you never got the request or the internet to them is slow. There could be orchestration failures between your backend and your agent code. And you'll notice here something interesting that the agent code itself is not inside the backend. This is a pattern that we definitely see quite often. A lot of agent runtime, including what we offer in Tanzu platform with the Tanzu platform agent foundations, is the ability to kind of run the agents on their own life cycle. The agent becomes kind of like a service that your existing backend can call into. And of course, your agent is going to call the foundation model. So in follow-up webinars, we'll cover these kind of more productionized version of this. So before we get into the code, let's level set with everybody on something important, which is the agentic loop. And what is the agentic loop? So we've already explained that what distinguishes an agent is that it has to be able to plan and act. So for the planning, we're going to use the model in order to figure out what the user wants and what actions need to be taken. And then we're going to get that to execute some tools. And this is really a key feature of models called tool calling. And I'm going to quickly review it with one slide, then we're going to jump into the code. Now, the tools are going to be all the APIs you want your agent to call in order to accomplish the task. So when we have the tools are the things that you provide. They don't come with the model. You have to provide the tools to the agent. Then you've got the brain, which is the model that you rent out from an AI lab of some kind. And then when you put that in a loop, you have the ability to reason and plan and then interact with the environment. So this is what people call the agentic loop. Spring AI is probably one of the easiest things in the world to use to do this. And you're going to see exactly how in the rest of the webinar. So let's review how tool calling works, and then we'll get into the code. So imagine you go to a model and you say, what should I wear in Amsterdam today? And obviously the model doesn't know because it's not in its training data set. However, what you can do is your application can include a tool. So you can see here that says, hey model, I have this tool called Get Weather, and it takes a city name. And you can imagine the description would be like, I retrieve the weather right now in that said city. So when you send it to the model will not give you a recommendation on what to wear today. Instead, it will request the calling application to invoke the get weather tool with the argument of, in this case, Amsterdam, which it extracted from the input prompt, right? So that goes back to the app. Spring AI will, invoke that tool for you. And so that tool could say something like it's 12 degrees and raining as the tool response. But in the next request, we also include the previous conversation history. So now the model knows you're asking what to wear today in Amsterdam, but it also knows what the current temperature, the weather in Amsterdam. So it could say something like wear a jacket and get an umbrella, right? So the idea here is that you can bring your own, you can take your existing APIs you have in your company, and then you can expose some of those APIs as tools that the model can call. And that is how you get to providing the right ability for the model to act and do things in your environment. So your job as the agent developer is to build those tools that are relevant for your use case and to create the harness around those with the agent. Okay. So what are we going to do today? We're going to create this little agent called Jarvis. You can say things to it like, I need to organize a business dinner for 4 people at 6 p.m. tonight. I'll be at the office till 5:30. One guest is vegetarian. The dinner must comply with company expense policy. Plan the dinner and book the reservation. Now, you can see from this, there are some explicit constraints, like it's at 6 p.m. tonight and there's 4 people. There's some implicit constraints. Like when I say I'll be at the office till 5:30, well, that means I need to get to the restaurant before 6 or by 6 p.m., which means it should know where's my office, right? Like how is this agent going to know where's Adib going to be at 5:30 so that it figures out to get a restaurant within travel time allowance. It also says it must comply with company expense policy. Well, what's that? Is that like $50 per person, $500 per person? Who knows? So part of working with these agents is to or building them is to actually get them to figure out what is the user trying to do, what's the human wanting. So this is a quick architecture diagram of the code I'm about to show you. Basically, what we're going to deal with is we have a GUI, which is a Vue.js application that has a chat panel that can talk to a backend agent. But in this inspector, there's also like a state viewer that lets you see the internal state of the agent. And there's a trace viewer that kind of lets you see what the agent has been up to and how it's making its decisions. And then the agent itself is going to call out to ChatGPT in this case. So that's the AI provider. And then for the environment, we have a bunch of tools that I've included that we will be able to do the scenario with. Okay, so let's switch to the IDE. All right, everybody see my IDE here? All right, I
We
assume
see
so.
it, yes.
Okay, excellent. All right. So let's go into the inspector. Am I here? Oh, see the scaffold inspector. By the way, if you want any of this code, it's right there. That's the place where you can get it. It's all on GitHub. So we're going to do npm run dev. All right, I'll take that, copy, and we'll go over here. All right, so as you can see, this is the thing that the kind of the GUI that we're going to use to talk to it. You can see it says up here it's disconnected because we have to first run an agent. So in our case, this is our meal planning agent. There's 4 versions of it here. So I'm going to go through these 4 modules, and each module is going to add a new capability. So the code in 02 is a copy and paste of 01 plus new code for constraint checking. 03 has everything in 02 plus new code, and 04 has everything in 03 plus new code. In this case here, in order to kind of make it easy to build this demo sample, we've got the inspector here. That's part of the scaffold project. And then there is like a library here that's got some some controllers and things like this to kind of make it easier to have the JavaScript front end call. And so we don't want to kind of have the noise of the mechanics of that. And so there's a very lightweight kind of demo scaffold that allows us to do what we want. So what I'm going to do here first is we will go and we will run this application. And okay, that is what happens when I. All right. Sorry about that.
We haven't received any questions just while you're doing that there, Deeb.
Mhm.
But anyone, if you guys have any questions or comments, please submit them using the Q&A tool or through the chat, and Deeb will answer them live here.
I don't know why, but I decided to upgrade to Java 25 like 10 minutes before the webinar. So you get to watch me
We like to
chat
keep it
intelligent.
exciting.
Yeah. All right. So now that I've got my Spring Boot app with the agent running, I go back here to my GUI and you can see it says connected. So let me show you kind of the flow that goes with this, and then we'll look at the code for how it works. So you see it says, "Hey, I'm Jarvis. I specialize in planning memorable dining experiences. Tell me about your occasion." I'm just gonna say hi to it. I'm not gonna say anything. Now what's going to happen is that it's going to come back. You can see down here in the event, it says the session has been started, and the agent is in a state of gathering requirements, and it's missing 3 required fields. Now, what's interesting about our setup is that we have this agent state here. So what you see here is like a little bit of markdown that shows us what does the agent think the user wants to do. So in our case, we have requirements, and our requirements is that we need to know how many attendees are coming. We have some information about the meal, like what's the budget per person, what date, meal type, various other things. And right now we can't begin planning because the user hasn't given us information. So what the agent is saying is, well, what date are you thinking about the meal? So let's say tomorrow at 6 p.m. Okay. Now what you'll see is it will update the state, right? And you can see here it says 1800 and it's saying July 23rd, which is in fact tomorrow, right? So what does this mean? Well, it means we're starting the loop where we are trying to gather enough information to start planning. So you can see up here in the state that now this is at revision 2. I could actually go back and this is what originally it started out, right? So it's one nice things about this UI is it helps us understand what our agent is up to. Okay, so how many people will be saying? Let's say 2 people. 2 people. One is vegetarian. All right, so let's see what it comes back with. You can see here now for the attendee, it's got a dietary constraint of vegetarian, and it kind of added this over here. Now, we don't know how many kilometers they're willing to travel. We don't know their name. We don't know where they're starting from. We don't know if they're driving, cycling, walking, taking public transit, right? And so what it's doing is it's kind of summarizing the state. So if I do something here like this is a very important customer meeting with a VP, right? We should see it actually update the additional requirements. Very important customer meeting with a VP. So now if I say something like, looks good to me, it's asking me to confirm. In this version of that, it doesn't yet do the planning because we haven't programmed that yet. So you can see here the events that we went through. It started the session, it kept gathering requirements, it confirmed the requirements, There's no missing fields. You can't really plan a dinner if you don't know how many people and you don't know what date and time. And that's the minimum you have to provide for it to make some suggestions. Okay, so let's go take a look at the code for this in Spring AI, and we'll see how it works. Okay, so standard Spring Boot application. And in here, what we're doing is in my little scaffold, I just basically created an agent handler interface. And that one just says, please tell me the name of the agent, the initial message to display, and then there's an on message that says, here's a session with the user, here's what and then you pass in the message. Okay. So I'm going to go here back to this guy. So what we do here is, it's Jarvis is our agent. This is the text that we saw over here, like to open this up, right? And then every time we get a message, what do we want to do? So the first thing we want to do is we want to kind of create our own context, our own kind of like information. And that's represented in this Java class, the Jarvis agent context. And here we are saying we would like to know what the user requirements are. So let's go and look at this. Because we want to capture the user requirements, how do we represent that? Well, it turns out you can just represent it as a regular POJO, right? So you can see here, I've got the user requirements. It's got a meal Java class, and it's got a list of attendees. If we look at what a meal is, date, time, party size, meal type, purpose, right? All this type of stuff. Hold on a second. Let's actually see what that looks like. Hey, doesn't that match exactly what you see here? It sure does, right? Because all I'm doing is I'm taking this Java object and I'm turning it into a JSON. That's the state. So what I'm trying to communicate here is that when you build an agent, you still kind of do the same sort of stuff you do when you build anything else in Spring and modern apps. You do a lot of JSON. Um, so So this object hierarchy here, like for example, dietary constraint, let's take a look at that. There's some known ones like vegetarian, vegan, kosher, whatever, right? Meal types, breakfast, lunch, brunch, dinner, right? Like noise level, quiet, moderate, loud. So you can see here what I'm starting on isn't anything like AI specific. It's just breaking down the problem into what is the minimum information I need in order to get the agent to do its thing? Imagine that you actually were working with an event planner, like a human who organizes business events. They probably have a form that they would ask you to fill out when they're interviewing you to find out what kind of event you're looking for, so they could plan that, right? So you could think of this as the facts that are going to feed into the agent. So first thing we do is we kind of create an empty version of this, of these requirements. And then what we will say is we're going to run an alignment pipeline. We're going to take the user's message and we're going to extract requirements. So let's go to that. And in order to figure out what the user wants, first we call this extractor. So let's go here. And this is the first place you're going to start seeing calls with Spring AI. So requirements extractor is just a regular Spring POJO, a Spring component. And what we're doing is we're creating a Spring AI chat client. And in the chat client, we're saying, we're setting a system prompt that is saying like, hey, you're a structured data extractor for a business meal planning agent. Because what we want to do is we want to take the natural language that the human types in the chat window, and we want to convert that into a data structure that we can work with. So you can see here, it says your job, given the current planning state and a new user message, return an updated user requirement JSON that merges the new information. So here's where we're telling it about like, what's in a meal, what attendees mean, some rules to follow when it's extracting stuff. And that's the system prompt. So let's now take a look at what happens when we call extract. Well, we pass it the current version of the user requirements, which is that Java object I just showed you. We pass it the new message that the user typed in. And we just basically say, Let's create an actual prompt that we're going to send to the model and say today's date is whatever is the date today. You can see local date.now to string. And then we're putting in the current state, and in there, we're blasting in the JSON version of the current requirements. And then we put the user message over here, and what we get back is a new Java object. And this is one of the most amazing features of Spring AI, because when I call the model, Spring AI will, template this stuff out, replace these things with curly braces with their values. But when I say .entity, what Spring AI does is it looks at this user requirements.class and it generates a JSON schema from that object. And it automatically configures the model that you're calling. So the model knows you want JSON output, not free-form text. And so this is the bridge between the deterministic world of software we know how to write and the probabilistic world of models. As you can see from this, from the perspective of the agent, it just says, here's my current requirements. Here's what the user asked, the new information from the user. Okay, tell me how that impacts the user requirements. And what comes back from this is a new version of the user requirements. I'll just pause here. Does anybody have any questions? Okay. Next is we would like to determine the status based on what's missing and all of this. So now we're like, okay, we extracted the user requirements. Can we find the missing like, I want to know, are these requirements good enough for me to start planning as the agent? So first, I'm going to call this assessor, which is just another component. And this one is first looking for required missing fields. Notice that you give it a meal and it's just checking, do I have a date, a time, and a party size? Like if it doesn't, it'll be like, hey, let me just tell you, these are all the fields that are currently missing, right? Date, time, and party size. This is how, when we were here and we just said hi to it, it basically said, what date are you thinking about for the meal? Okay? Because these things were missing. So once we know what's missing, we can then determine what's our status, which is basically a way of saying, do we have enough information to plan or not? And for this, we take a list of the missing fields. We take a list of what's the current status, and the alignment status is like I'm gathering requirements from the user. I'm confirming the requirements with the user, or the requirements have been confirmed by the user, right? So that gives us a way to do things. So if we do something like has missing fields, okay, then we say like we're gathering requirements. If the user has confirmed, okay, then where requirements are confirmed. So how do we know if the user has confirmed? This is kind of interesting. Well, we basically check to see if we're currently confirming requirements and is unchanged, aka I call java.equals. Why can I call java.equals to know this? Very simply because I've converted the user's freeform text into a Java object. And because I've done that, I can do Java hashcode equals on it, right? And that will allow me to know if the last message the user sent, which was, for example, here when I said, looks good to me, if we look at the version, that was version 5 of the state. And if we go to version 4, they're identical. If you deserialize version 4 and version 5 and compare the two Java objects, they'll be the same. That's a signal that we've gotten the user's requirements. Okay. So let's keep going with this. Back to the requirements extractor. Nope. Over here. All right. So step one, just kind of high level. We figured out from the freeform text what the latest version of the requirements are. Then we checked if the requirements have been updated. Now we need to compose a reply to the user. And in the compose reply, this is where we can basically check our state. If we're gathering requirements, we can ask for the missing fields. If we're confirming requirements, we could suggest a follow-up, and then we can ask for a confirmation. So let's see what it looks like with this composer. So our composer is, again, another component, Spring component. And here we have another chat client. But notice that now we have a different system message. So when we're interacting with the model in these various configurations, in these various stages, we're making requests to the model, but they're completely isolated contexts, like model contexts. They don't know when we're composing the reply, it doesn't have the history and the back and forth that happened with the when we were gathering the requirements. So you see here that we tell it it's a professional executive dining assistant. You help plan business meals. We give it some tone about how to write, like be brief and conversational and human. And then when we say something like ask for missing fields, then we would say, hey, we need to know the following before we can start looking for a restaurant. Write a brief question asking about it. So here we inject the fields that are missing, and then here we inject the current requirements that we have. And based on those two, it creates an answer, and that's the answer that we send back. And so if we look to see how that played out here, when I said hi to it, it said, what date are you thinking about for the meal? Because there were 3 fields that were missing. And it just decided to ask, what's the date? Right? When we're asking for confirmation, we do something like, we have enough information to start searching for a restaurant, summarize the requirements in a readable way, and ask the user to confirm whether it's correct or not. If the suggested follow-up is relevant, mention it casually. So here where we say, okay, here's our current requirements, and here's the suggested follow-up. And what we want it to do is to kind of generate that suggested follow-up, which is something that we do, I believe, ask for a missing field. Where is it? I think it's somewhere in here. Yeah, I think we have it in the caller. Okay. That's where we go and we kind of get that from a different model call. And in this model call, we're just saying, hey, you're an executive assistant, you're planning meals, and given the current requirements, suggest one thing that would be most useful to ask about next. Think about what a thoughtful assistant would do, right? And in this example here, we just say, here's the current user requirements, AKA, here's our actual JSON text, like literally this text right here. And we let the model kind of go like, hey, what would be kind of a good thing to ask about? Like they didn't tell me the budget, right? So maybe I should ask about the budget. So hopefully you're starting to see from these examples, where did my IDE go? You're starting to see how we can bridge between the world of determinism in Java and the world of non-determinism in the model to kind of try to align on the user's requirements. So let's go back to the requirements aligner. And so we go through here, again, extract the requirements, determine the status based on what's missing, and then we use the model to generate a reply. So we're using the model 3 times. We're using it to interpret the user's intent, convert it to Java code, to a Java data structure. We're using that data structure to determine whether we have enough information to keep proceeding. And then we're using the model again to compose a reply. And that's what we return. So that was, once we have this here, we simply just log it and, we literally send a reply. You can see here, update state. I'm basically returning Markdown with the JSON containing the user requirements directly. That's what you see here, just the Markdown rendered in the JavaScript. All right, so that was the first example of this, and we kind of didn't take the code beyond the basic kind of we now have agreement from the user that we're ready to start planning. All right, so let's close this out. Let's go to the next one and we will start this one here. So in this one, actually, there is no, oh, what's that? Bug with IntelliJ or something? Huh, okay. Weird. All right. Okay, I don't know how to fix that. Like this. Is that IntelliJ or is that whatever? Um, so what we're going to do with this one is we're going to start thinking in terms of how do we know, that's why it's called constraint checking. How do we know that a proposed solution meets the needs of the user or meets the user's requirement? So in here, there's a set of constraints that we're adding, and those constraints are going to check the proposed candidate restaurants against some criteria. And we have different groups of them. So we have some deterministic constraints. For example, does it meet the budget? Does it meet the noise level? Does it have enough travel time? We also have some other constraints that are purely like LLM as judge. We ask it, does this look like a good restaurant, for example? And we have some that are hybrid. So before I do that, let me explain to you where the data comes from. Within this, there's a restaurant data project, and that restaurant data project has a menu item here. Oh, sorry, it's basically fake data. So what I did is I didn't want the sample to depend on kind of making API calls and you need real API keys. So instead, what I did is I used Claude Cowork and I asked it to scan some of the downtown Toronto restaurants. If you're a Toronto person, you might know some of these restaurants, and kind of create like a fake database of restaurants. So you can see like our database has things like Toroni on Adelaide, where you can find the menu, the noise level, the price range, the description. So there's about 15 different restaurants, real restaurants in here. Okay. And then I had it also I had Cloud Cowork extract the restaurant menus. So, for example, these are all of the actual items on their menu whenever I ask Cloud Cowork uh, to extract it, right? So based on this one in here, there is like, for example, a restaurant service, and the restaurant service will just literally read that JSON file, and given a restaurant ID, it will return the restaurant description, which is just a Java record of what's in the JSON. This is a cheap and cheerful kind of mock data for the agent to make use of. Okay. So going up here, what we're going to do now is we're going to basically say, let's take something like a budget check, right? Just have a regular Spring service, budget check per person. You inject it with the restaurant service, and then you say, here's the requested budget, here's the restaurant ID, tell me if it's within. And you can all imagine what that looks like. You're just doing some basic math to decide whether it passes or fails. So again, when you're dealing with these, it's like, what do I return from that? We return an enumeration, right? Like you can use the standard types in Java to your advantage when you build these things because, well, why not? Like that's what you know how to use, that's what's available to you. So in this example, we're like, hey, if it passes for sure, maybe your budget is $100 a person and the most expensive item on the menu is $50. You're good. If it can fail because your budget is $50 and the cheapest item is $60, right? And maybe because maybe it's your budget is $75 and, depends on what you buy, you might go above or below. So that's an example of a check here. And similar stuff. We check the noise level, we check the travel times. So let's take a look at something like hybrid, like for the dietary constraint as an example. In this case, we want to be like, you know, uh, like if there's like a vegetarian or vegan or whatever, is this restaurant looking like a good thing? How do we actually determine this? Let's take a look at the check here. So this is where we can start using the model itself and doing some other stuff. So what we want to do is we can see here you're judging whether a restaurant's main courses appear suitable for a group's dietary need. And then we give it some rules we want to do. And then we say, here's the list of dietary constraints that you have to do. And then here's the actual main courses. And then we call it, and then we ask for Spring AI to convert the answer not into words, but to a JSON response. So you can see I'm actually passing it the Java class that says, please tell me what the status is and explain the rationale that you have as an agent, as a model. Like, why does the model think this? And the fun, interesting part here is we don't want to do things like the appetizers because guess what? Everybody has a salad. Like most restaurants have a salad that would come across as being a reasonable vegetarian option, but that's not a main menu. So what you want to do is you want to do some sort of like pre-processing on the menu. So for example, filter to this is basically trying to remove the appetizers from the menu in order to determine if it's vegetarian, if you're vegetarian or not. Like to just only keep the main menus. We don't want the desserts, we don't want the appetizers, we just want the main courses, right? And so that's why I'm calling this a hybrid check because it's using the model and the not the model too. Some stuff. Some things that you can do now are be like this one here is meal suitability. This is a pure LLM judge using the non-determinism of the model. And what we're doing is we're just basically saying you're judging whether this restaurant appears like a good choice, right? And you're telling it the meal context. Just remember in my example, I said here like this was a meeting with an important vice president from a customer, right? And we're just wanting to get the opinion of the model. Hey, model, do you think that this restaurant is good for this type of meal? Right? So if it was in there showing up like a comedy club or maybe like a pub, maybe that's not the place to take your very important VIP customer. So all we're doing in this one, if we look now at our agent, is we are simply having this extra checks. In fact, this doesn't really do anything. So let's move on to the next one to do that. So in the next one here, let me actually run this one and then we will actually see it work. So let's run this. All right, we will let's refresh this one here. Let's create a new session. Say test. All right, so I'm not gonna go through the height and all this. I say dinner for 2 tomorrow at 6 p.m. with a very important customer, right? All right, so we can see here it's I don't see any cuisine preferences, budget, noise level. I'll say, oh, I'm gonna say he's vegetarian and the budget is $100 per person. Okay. Now we should see it update here to a budget amount. And we should have that one of our attendees is vegetarian. Yeah, let's say something like looks good to me. Okay, so now you can see here it made a bunch of recommendations, right, for restaurants. and it's telling us like, where it is, why it's recommending all of that. So let's actually now take a look at the code to see how did it actually make those recommendations? How did it come up with this? Okay, so we have again all of the code from the previous one, but now we added this planning module. And here we have our planning tools. And let's look at the agent handler. Right? So we still have our good old handle alignment. We have this new handle planning. And here what we want to do is we want to basically say, well, we've got the requirements. Let's call the restaurant planner, which is just a regular service. And then here is where we're going to call the model. So you can see we are telling it that it's again, a meal planning agent or a meal planner. But again, this chat client is completely independent of the other ones. So even though we're calling the model multiple times, these calls like don't know about each other. The model doesn't know and hold state. The model is completely stateless. So we're telling it the strategy it should use for identifying the restaurants, like search for available restaurants that match the date and time, pick the most promising candidate, review the evaluation results, like the constraints that we had earlier, only present the restaurants that pass. And then we give it a tone to write. Now, here's the fun part. You see this one right here? There's a very important line. What we're going to do is we need to provide a set of tools so that the model can like actually do a search. So if we look at this, what is this planning tools? That's this Java object over here. And this Java object is another um, Spring service, except that we have methods on it which have this Spring AI at tool annotation. So because we put the add tool annotation on the find available restaurant, that means that the model knows that it can request Spring AI to invoke the find available restaurants tool. And you can see here we've told it we want a date, a time, a party size, and a neighborhood to search for the model in. And we what do we do when we get that call? Well, guess what we do? We call the availability service, which is our kind of wrapper for our API that's going to find available restaurants in those locations. Once we have something, we kind of compose a response, we turn it into a string, and we return it. We have another tool, get restaurant details. This one says, I give you a restaurant ID, and this thing is going to give it back the details about the restaurant. In this case, we just convert it into a JSON and return it. So that would be inclusive of like the overview of the restaurant. We have another tool, check restaurant candidate. Does it meet the user's constraints? Given a restaurant ID, tell me what it means. So what do? We retrieve the restaurant from the restaurant service, and then we invoke the check service. And this was a service that literally runs every check it knows about: noise level, budget, travel time, dietary, meal suitability. And you saw when I showed you these just a few minutes ago that some of these were in fact calling the model, like dietary suitability or meal suitability. And some were 100% deterministic, like budget per person or noise level. All right. So if we go back here so you see this idea of the tools that we have to provide for our use case. Then if we go back to our planner, well, what is our planner doing? We're just telling it what tools are available to the model when we invoke it. So when plan is called, we just say find restaurants for the confirmed requirements, and we blast in the JSON object with the requirements that we have. We call it, and then it returns what happens. The model starts calling the tools, and that's how we ended up with an actual response here, right? So if I say something like, tell me about Planta, so I say something like, tell me about Planta versus Aloe, Aloe Bar, right? It doesn't know what to do with this because like it made some recommendations, but all it's doing is like it's kind of being stupid and it doesn't yet know to actually book the restaurant. That's what we do in the last example in here. All right, let's stop this one here. This is what's called decision support. So now we're going to do a little bit of RAG over the answers. So once it makes some recommendations, you can kind of ask it like, tell me about this versus that restaurant, right? So let me demo that so you get a sense of what that looks like. Because we're almost out of time here. We got like 3 minutes. The test and say dinner for two tomorrow at 6 p.m. $100 per person. One vegetarian VIP customer. All right. It's taking a little bit more time here because it's actually making all those tool calls. So it's making multiple tool calls to ChatGPT. In this case, I'm using ChatGPT Mini in order to process this request, do the planning, and all that type of stuff. So let's give it a few seconds here. Am I having an exception in my log? Maybe I am. Demo fail. No, no demo fail. You can see here it actually figured out. Uh, okay. I was just being slow. All right, cool. So I'm going to say looks good to me. And let's see if we get back a quick list of recommendations, and I should be able to book it and ask questions. In the meantime, does anybody from the webinar have any questions for me?
Any additional questions coming in, Adib? And I think you did note that we are getting close to time, so we can wrap up here. We do want to let the folks know that we do want to have Adib on for future events. So if you don't have any questions now, make sure to save them for when we see Adib in our next webinar. All right,
Yeah, I
back
mean,
to you,
if
Adib.
if there's any questions, maybe I could just run over a minute or so, and then maybe I can answer them if you don't mind. So let's
I
say,
don't mind at all.
tell me about uh, Planta versus Richmond. All right. This is now going to come back with an answer. I can say something like, book, Planta, or something like that. What we're doing with this in the last one is that we're kind of transitioning state. And you can see here it gave me a comparison. I don't have a lot of time to dig into the code, but it's more of what you've seen so far with kind of like decision support. It's just another thing. And then now we're telling it, it's a meal planner, and then the user has a question about these things. So when we send it, we can say to it, here's the confirmed requirements, here's the list of restaurants, here's the user's message. Okay, can you answer the user's questions based on this information here? And that is basically what it does. So I hope I've given you a good overview of how to do this. If there's one thing you take away from today, it's that architecture determines a lot about your agents. I hope I showed you a little bit about how to build an agent. So, any questions?
It looks like we did get something come in. Would you recommend a book on Spring AI? Was the question.
Excellent. Well, I would recommend a book called Spring AI in Action. All right. This is written by Craig Walls, who is a member of the Spring team, and is an amazing author and has written a lot of books on Spring. So this would be a good starting point. But also keep in mind that AI is so fast moving that stuff is changing, right? So don't be surprised if there's a new edition of the book is coming out, or something has changed since the book was published. Okay. Any other
Thank you, Dave.
questions?
Thank you for the question. No other questions.
Okay, excellent.
All right. Well, do want to just say a special thank you again to you, Adib. Thank you to Camille here in the background who did help out with setting up this webinar. Most of all, thanks to all of you guys for joining us today. We do plan to have Adib on future webinars. So if you enjoyed today's content, we look forward to having you join us for future webinars. This has been recorded and will be available on demand shortly after the end of this presentation. All right. Thank you, Adib. Thanks to all of you guys. Have a great week. See you guys soon.